This is a nice simulation that I'll give you guys a link to so you can play around with it a little bit. You can look at a lot of different charge configurations with this simulation if you want to see what the electric field looks like. For this particular demonstration, I'm using the conducting box setup. And I want to show you guys what happens when you move a positive charge in and around a conductor. So here you guys should be able to tell that this conducting box has a net positive charge. I can tell that because it is generating an electric field. The electric field is pointing away from the conducting box. And you can even see that, in fact, the electric field looks like it's a little bit stronger. That's at the corners, at the pointy bits where we'd expect. And in fact, I can change what you're seeing here to electric field lines, and that might show that even better. Okay, so they're a little bit denser here at the corners, just like you would expect. Okay, so right now the mouse is set to move object, which means I can actually click and drag this box around if I want to. But I'm going to adjust, and I'm going to set the mouse to add a positive charge. So add a positive draggable charge. All right, so I'm going to put it up here initially. Okay, and you can see what happens when I put that positive charge up there. It does change the field, of course, above this conductor. It's creating its own field, and that's superimposing with the field of the conductor itself. But you can see the conductor is still shielded inside and even inside this cavity from this excess electric field outside the conductor, okay? And you can see here, notice that, again, even when we're superimposing the field is always going to be perpendicular to the surface near the conductor, okay? I can drag this charge all around, and you can see, again, just as you would expect, you still have shielding inside my conductor from this external electric field. And you can even see what happens if I drag the charge inside the conductor, okay? So what I want you guys to notice is if I drag the charge inside the conductor, okay, again, the conductor itself, the material, the electric field is still zero, but outside the conductor, the electric field has changed. And in fact, if I add more and more of these charges, okay, I am in fact causing the electric field outside the conductor to be stronger and stronger, okay? Every charge that I add is going to increase the strength of the electric field outside the conductor. But notice I can move these charges around. I can move them around, and that doesn't do anything to change what the electric field looks like outside the conductor, okay? So when I added charges, that changed the strength of the electric field, okay? Because now the shielding charge on the inside, there's more excess negative charge on the inside of the conductor. And the more excess negative charge there is on the inside, the more excess positive charge is going to be on the outside of this conductor, and that's going to give you a stronger electric field outside the conductor. But it doesn't matter where these charges are inside the conductor, okay? So what does change is how that negative charge in this case is distributed on this inside edge. It's going to be distributed non-uniformly as it tries to block the electric fields from these charges inside the cavity from being in the conductor itself. So you're going to get more negative charge here in this case and less negative charge here, okay? But that doesn't affect the way that the positive excess charge is distributed on the outside of the conductor. So this really is a shield. You really can't tell looking from the outside what is happening to these positive charges inside the conductor. And I think that's pretty cool.